Welcome back, boys and girls. Today I'm going to be doing a introductory video to ASP.NET Core. So if you're a beginner, if you're somebody else looking at .NET 8 and you're like, okay, I want to check out the ecosystem, I heard you can build web servers, this video is for you. And perhaps you've actually taken a look at ASP.NET Core and you've already built something with it, but you don't quite understand how the whole thing pieces together. So, yep, this is a video for you, for beginners effectively. The reason I'm making this tutorial is because a lot of the tutorials out there, I think, frankly, are crap and don't explain the fundamentals of ASP.NET Core, and people just go in starting building features instead of understanding the core foundation of a web server and the architecture of ASP.NET Core. So if you don't think you have a solid foundation or a place where you can start from, this video is for you. Don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to ask them in the comment section. I have a C# course that is out. If you would like to know C# as I do, I highly recommend you take a look at it. With that, let's go ahead and get started. So the first thing is I'm going to be using Fleet for my development environment. If you don't know what Fleet is a JetBrains IDE. The first time I tried it was about 2 years ago. It was crap. Now it's a little bit better. The reason I'm using it is because I want to show you that there's tons of tools available to work with C#. You can use Visual Studio, you can use VS Code, you can use Writer, you can use LinkPad, you can use SharpLab.io, you can use Fleet, and that's what I'm going to be using. I'm going to assume you're capable of setting up VS Code with an extension or just downloading Visual Studio with the correct installed packages or the .NET SDK. The thing that I'm going to make sure that you go ahead and check is that when you type in .NET -- version at your terminal, you're going to see 8.0.1. Okay, so we're on version 8. Now, if you type in .NET new list, these are a bunch of templates, effectively new projects that you can create. We're going to be focusing on a web server that is empty. So we're going to be using the web short name and we're going to get an empty ASP.NET Core application. Okay, so .NET new web, and then we give it a name, and I'm going to call it beginner tutorial. Okay, I'm gonna change my directory to beginner tutorial, and I'm gonna open Fleet here. So same as code, you just type in code and dot, and I get a window that looks something like this. None of my keybinds are probably gonna work here, so I'm not gonna be telling you how I did this, how I did that, etc. Here I get a solution view. Nobody cares about the solution view. Close it off and try to work with it as if it's a folder view. The first time you start this up, you get a program CS that looks something like this. You go ahead, open up your terminal. Open up my terminal. You do .NET run. Your web server starts. You go over here and you see hello world. So what other tutorials go ahead and teach you is how to actually get other things on here, maybe like something like authentication, a form, how to post stuff. And what you really learn is how to recreate those steps and not really what forces those steps to actually work. So that's what we're actually going to be taking a look at. For this, I'm going to be opening my network tab or developer tools. So over here, I refresh the page, and this is going to make an HTTP request. Let me see if I can make this a little bit bigger over here. So an HTTP request. Let's go ahead and make a file. Test.txt. Let's come back over here, and it looks something like this, right? So we make a get, and perhaps we're adding some headers. So here we can see on the request headers, there are some cookies that are being attached over here. But yeah, let's say, there we have it. There's an accept header and so on, yada yada. If we have a post, we have something similar that is going on over here. There's a bunch of headers, and perhaps there's a body over here that looks something like this, either JSON, or perhaps this can look like a form. So for example, name is Bob and surname is Fu, or something like that, right? So the HTTP request, what I want you to understand is you're effectively sending a string. You're sending a string to the server. Okay, this is all just a string. I don't know if I can preview the raw request. I don't think I can, but think about it like this. You just have a string that you send somewhere. So then once you actually have a string, you can say, okay, let's read the first line of the string. Let's split it by space. And what do we actually have? We have a post, we then have the address, and perhaps we then have some kind of path, some kind of other part to the path. And the simplest thing that you can do is you can just say, okay, let's split by / and get this part, and if we have part this and we have part that, you can say, okay, I want to execute one logic or the other logic. And what I'm trying to get at here is to first understand that what you have is you have a request, a string that you send. This string is going to be received by your HTTP server that you're spinning up over here, the web server. Once you process that string based on some kind of logic, you're going to go ahead, write it back. So to get a little bit more of a feeling of that process, we're going to start off with the first core concept that you need to know about ASP.NET Core, and that is middleware. Okay, middleware is what allows you to process an HTTP request. It's effectively a chain of responsibility. You have many middlewares, one after another, trying to process a request. So how do you get middleware? On here, on the app, you say use, and on the use, you're going to get two things. You're going to get an HTTP context, and then you're going to get next. Let's give this a body, and this will have to return a task. So we're going to make this asynchronous. We're going to await for next, and this should compile. So let's give this a little body. So we have something like this. If you're a beginner to C# and you're looking at this, you're like, okay, hold up, I don't understand anything. If you're coming from a different programming language, you may say, okay, I can see there's a asynchronous lambda over here, and I'm awaiting something that's called next. And then there is also this HTTP context, which we don't know what it is. How do you know to put these parameters over here? How do you know to put this over here? So you need to effectively know the C# programming language in order to understand what is here, but let's quickly go over that. So if I hover over use, I'm going to see that the first parameter is this iApplicationBuilder app. So this is something called an extension function. You can go ahead and look for the syntax of that. And then the second parameter is effectively a function definition, which is going to accept a first parameter of HTTP context, second parameter of a function that is going to return a task that is available, and then is going to be returning a task in and of itself. Because we're marking it asynchronous, it's going to return a task, and then here are the two parameters. The first one is HTTP context, the next is the next middleware that we're going to be executing. So let's actually go ahead and copy this across over here. I'm going to format the code. And over here, what I'm going to do is say console, write line, and super simple, say hello1. And then over here, I'm going to say hello2, just so we understand that these things are going to execute in order. So for me, in order to not keep canceling and restarting my application, there is actually a .NET watch, and I like to supply a flag no hot reload, so that the application actually restarts fully every single time I make a change. Okay, so let's come back over here. Every single time I'm going to make a request. So if I refresh the page over here, the middleware is going to execute in order. First, this middleware is going to execute, and then this middleware executes. Okay, so how can I change the execution of hello1 and hello2? If I go ahead and take next and actually just bump it up one line. So I'm going to execute the next middleware, which is this one. Before I print console write line, it is actually going to do it. So let's come back over here. I'm going to refresh the page, come back here, and here we see hello2 actually invoked before hello1. So this is what I mean by chain of responsibility. You're effectively defining, okay, this is the first thing that is going to handle this HTTP request, and then the next thing is, well, the next middleware that should execute. You're effectively deciding where should the next thing happen. The other thing that matters is actually the ordering of these. So if I drop down my terminal for a second, I take this use, I will place it over here, and the application again will restart. I'll come back over here. The order is effectively 2 in 1, but this time if I take this one over here, I place it at the top, so we don't actually get this wacky order, which is we're just going to get 2 and 1. Okay, so again I refresh, and there we have it. So 2 and 1. Cool. Now that we understand that this is our request processing pipeline and the order matters, and that the next thing specifies when the next pipeline is going to be executed, we're going to remove the console write lines over here, and we're going to try to actually interact with the HTTP context. As I said, if I come back to test.txt, an HTTP request is just a string payload. ASP.NET Core have gone leaps and bounds to effectively parse this whole thing into this HTTP context. So the HTTP context is going to have a thing like a request. This is the request that you're making. On here, you can find things like the body. So for example, this thing which is going to be included if you're posting. For example, perhaps we can check out the method or the schema of the request, and perhaps the headers. Okay, if you're somebody unfamiliar with HTTP, you might be getting, okay, how do I know about body? How do I know about all these headers? How do I know what is what, and how do I actually learn this stuff? So what you do is you will pause the video after I explain this, but you can do this for anything. You're gonna open up Google and you're gonna look for HTTP request anatomy. And you can do this for literally anything. So for example, let's open up this Better Programmer or whatever this is. So they're going to explain to you, okay, what these things are, what the host is, etc. And I think maybe one of the better things will be to like look at images and stuff like that. So for example, you will see an image that looks something like this, or perhaps, I don't know, let's find a better one that looks something like this, okay? And then you can see here unique resource identifier. So this is a whole thing of its own, and perhaps you, instead of an HTTP request anatomy, you want to say URL anatomy. And this is where you can say, okay, this is going to be the protocol, this is the domain name, this is going to be the path. And because an HTTP request consists of a URL, perhaps you're going to find things like path of the URL, and then the query, which is again part of the URL that the request is being made to. Okay, if we come back over here, and again, we're going to try to interact with the request that is being sent. If we put a question mark over here, we're going to start to specify the query. Let's say a equals 5. We can start interacting with this query. So if we go to the query, iQuery collection. So if I can remember how to type, there should be a try get value here. And if you're using Visual Studio or VS Code, you should be getting better IntelliSense here than me. So let's do this. What key am I looking for? I'm going to look for key A. If I'm going to get this value, let's go ahead and enter this body of the if statement. The second parameter out here is going to be a bunch of string values. So out var what actual value is being supplied over here. Let's say console, write line, and just output this value. Okay, so the server is going to restart. I'm going to come back over here. I'm going to refresh, and nothing should be printed here because, well, we're not supplying a query string parameter. Okay, so I'm going to say question mark. So start a query string and supply 5. Come back over here. I'm going to see 5 being printed. Likewise, I can get information about the, what's it called, the path that is being executed. So let's take a look at the path. It's going to be a path string. Let's see if it actually is going to print it. So for example, 1/2. Let's take a look at this, and we're going to see, okay, here's the path. Here is the query string number. So a lot of the tutorials will jump to how to actually use these endpoints and stuff like that without explaining what I've just explained. So now that you understand that, okay, there's this middleware that you can basically access the path and you can access these query strings. Now you got to come up, okay, I don't want to be putting if statements here. I don't want to be, you know, having a bunch of this stuff, right? I want to have it as simple as possible. So what you do, as you generally do in programming, is you create your own domain specific language. Effectively, it doesn't have to be a different language from the programming language that you're using, but for example, this language over here, app.mapget, where you effectively specify a path and then a hook which is going to execute if this path is matched. This is a web server domain specific language. It's effectively a way to define these endpoints. And basically a lot of metaprogramming concepts, a lot of work has been put put inside of this build method in order to allow you to get this. And how you would usually encapsulate middleware is you would put it inside a use endpoints. So in this order, same as use anonymous middleware, you get use X middleware. At this point, use endpoints is going to be invoked. You can pass some configuration over here. It doesn't really matter. I'm going to discard the parameter over here. I'm just saying that endpoints should be invoked at this point, and then I go ahead to define my endpoints. Okay, so the endpoints that I define over here are going to be matched here based on these rules. So inside of here, we can expect a lot of logic, which is going to read the path, read the query string, and effectively place the information into here. So let's go ahead and define a method which is going to effectively match 1, 2 and capture the query string. So 1/2 and then capture the query string. So A, and let's say that this is going to be A over here. I'm going to make this an interpolated string and just place the A over here. Okay, wait for that to restart. Maybe I have some issues. Line 22. This is going to be the use endpoints. Not going to get into it, but you're going to have to use routing if you want to use endpoints. Okay, so that starts up. Let's refresh. And here we see the parameter that we're supplying over here. We're matching the route that we have defined over here, and then the query parameter is getting automatically populated. If we want, we can effectively say something like my param over here, and this is just going to be another param, my param, and again, let's template this in and put a comma over here. And we can see to an ABC based on the route. Again, I can specify any route I want over here, and that's going to be templated. So again, the reason we're explaining this whole thing and we're looking at this is so that we can understand that whenever you're placing something in on the app, you're effectively defining middleware, the order in which my requests are going to be executed. Each individual line here, use routing, use endpoints, is going to have some logic under the hood. For use endpoints, the logic is taking care of saying which path and am I trying to match on that path, try to get that lambda, and all of the information that is in your request, be it in the path or in the query string, try to map it to this lambda so the developer actually has to do minimal work. So again, with this, we're effectively understanding that we can send a string, we can process it, and then we can send it back. The process of sending back looks effectively something like this, and I'm going to use the second middleware for this. We're going to go to HTTP context request path. I'm going to take it over here. I'm going to grab the if, and let's say it starts with segment. My dash special. So this is my special route where if I hit this route, I'm going to go to the response, not the request. And I'm going to use write as JSON async, or I can use write async. So let's use write as JSON async. And here, let's say I'm just going to supply an anonymous object. Okay. And I'm going to put A5 over here again. Here we have it. Let's take my special. Server is running. Let's come back to the browser, and hopefully this won't crash. It might, but if it does crash, we can always take care of it. So there we have it. And there we have it, our JSON payload. So the reason I was saying that it might crash is because we're effectively writing the response over here, and then we're executing the next middleware, and it's up to the next middleware to really understand, okay, has the request been actually processed? But ideally what you actually want to do is you want to say, okay, don't execute any other requests if I'm already processing this request over here. Okay. The reason that is because once you actually start writing the result back, it is also going to be a string. If you're in the middle of writing a string down to your network card or down to the browser, and then you're going to try to say, actually over here, try to add something else, or try to add something more to write back to the body, you can't actually do it. So let's see what this looks like. So after we start writing the response with the body, we're going to take the response and we're going to say, okay, the headers, let's say my special header, and attach some kind of value to it. So just ABC, right? I'm just making stuff up on the spot. If I refresh this over here, the request is going to fail, and hopefully we're going to see an exception over here. I'm quite surprised that we still see, what's it called, at least something being returned over here, and it just doesn't explode completely. And we don't get a really good preview over here of this, okay? So the reason this is exploding is because we have actually started writing a request. So if you think about it, you get headers first in the same order over here, responses, and then the body follows. So it's first response headers, body. If you start writing the body, you have already sent the headers back to the browser. So you can't say, okay, actually browser at this position in the headers, there was meant to be one more value. No, the browser has already started processing the request and you cannot do it after. So there's a very well-defined order of execution. You send a request, you read the request, you execute some kind of logic, which are going to be mostly these lambdas or some kind of other tool that allows you to say, okay, hook into these endpoints over here, and then you do whatever you need to do. And then after it, we actually write the response. After the response is written, you're not allowed to do anything else to the response. You cannot have your server reach into the browser and start somehow manipulating the HTML. It always has to have that request response. If we actually want this header over here, we have to attach it before we start writing back the response. So let's wait for this to restart. We're going to refresh. We're going to take it my special, and we're going to see my special header over here, ABC. Let's come back to the browser and just make sure that we solidify the idea. Again, this is more about that you need to understand that ASP.NET Core is an HTTP server. I'm going to extend this middleware a little bit. I'm going to put -html over here. The response that I'm going to be writing is, let's say, write async, and I'm just going to put a big string over there. Okay, so the big string is going to look something like this, and I'm going to say, let's just put a simple hello world over here, right? So a little bit of a HTML, why not? Hello world. Let's come back over here. I'm going to refresh, and actually, did I say -html over there? Okay, -html. And there we have it. It is capable of realizing that it is HTML. And again, to really, I guess maybe to drive the point home, if we say content type, then this is going to be application/JSON, and we come back over here. You're going to see that this is how the browser reacts. You're telling the browser, your response is a instruction to the browser to do something. If you just purely send it HTML without telling the browser that HTML is going to interpret whatever text you send it differently. So, for example, if you do go and define something like this, where you're going to say my HTML endpoint over here, and you're just going to take the same HTML and return it. This is called minimal APIs, and they mainly work with JSON. You're not actually going to be able to parse it. So at that point, you're going to have to reach into the HTTP context, and you're going to say, okay, this thing is going to be producing HTML. Okay, so this was ASP.NET Core middleware, effectively the foundation of the ASP.NET Core web server. You have the middleware. Request comes in, you process it, and then you send a response, and that's the end of the deal. Let's talk about the second part, which is dependency injection. You're going to want to do some complicated logic over here, okay, inside the middleware. Your complicated logic, your classes, are going to depend on other complicated logic. You need to somehow compose this whole thing together, and dependency injection is the thing that allows you to effectively resolve dependencies and inject them into the correct places automatically. So let's go ahead and see, well, how does this actually work? I'm going to go over here and create a new file. This is going to be a GUID service. And the reason I'm creating a GUID service is, that was weird. Yeah, give me a class, why not? So the reason I'm creating a GUID service, this is just going to generate a new GUID. So let's say GUID equals GUID, new GUID. I'm not going to toString it, why not? Is this going to help me generate a property? I don't want AI. Okay, not to fret. You can type in prop. This pretty sure this works in most IDs. And yeah, let's say that this is going to be my ID, which I'm going to assign over here. Okay, so I have effectively created a class. When I instantiate the class, it is going to assign an identifier to the ID over here. The reason I'm creating a GUID service is because there are lifetimes to services. Some services exist for the lifetime of your application. And then as the request is executing, some services want to be created and persisted through the lifetime of the request. And then the other services, you want a new service every single time. Those are 3 lifetimes supported by ASP.NET Core, effectively global, called singleton. You then have the second one, which is scoped service for the lifetime of the HTTP request. And then you have the transient, which is new every single time. So let's have a look at this. A GUID service, if I go ahead over here onto the builder, we have our services. We are going to start off with singleton. We're going to register a GUID service, semicolon on the end over here. And the way that you get a GUID service is when you're using something like this, and this is internally going to automatically resolve the service that you're looking for. So for example, we're going to take GUID service over here. I'm going to drop this lambda onto a new line, and I'm going to place this over here. Okay, GUID service ID, and there we go. So the application should restart. I forgot the route. It was going to be 1 something, 1, 2, there we go. Okay, so there we have a GUID, and the GUID doesn't change. This is also getting automatically injected into this lambda, and it may seem a little bit magical. So at the point of effectively collecting the HTTP request, another thing that ASP.NET Core Framework is doing to the HTTP context, it is giving a reference to all of the services that you have registered over here. Where we have the console write line over here, let's say, okay, if we're supplying an A parameter on the HTTP context, we're going to have the request services. And then we're going to get a required service. We're going to go ahead and get the GUID service. And this is going to be our GUID service. On the value over here, let's just say I'm going to duplicate this over here, keep the console write line, why not? And just try to print the 80. Okay. So if I open up the terminal and let's go ahead and clear it over here, I'm going to refresh. There's going to be a new GUID because the application has restarted, but every single time I'm making the request over here, you can see it's the same GUID that I'm seeing here and here. Okay, and that is because it's singleton. So the first time that the GUID service is created, it is only created once. Okay, let's take the GUID service over here and actually put it near the next. So before we execute the next over here, which is the default for one of these paths, I really want to emphasize that, you know, when you're executing over here and it's a singleton service, it is global. And as we're going to be moving towards other lifetimes, you can see over here, the lifetime of the service is always the same. Okay, we're seeing the same GUID, even though that I'm refreshing the page, it's always the same. Okay, so if we change this to scoped, let's go ahead and comment this out, set this to scoped, come back over here. I'm going to refresh this once. I'm going to get 180. If I come back to the browser, or sorry, to the editor, I'm going to see the same identifier. So remember, scoped is for the lifetime of the request. If I come back and I refresh this, the GUID changes, but it's the same for the lifetime of the request. Okay, so effectively a new instance gets created as we're entering the middleware pipeline. So we enter it with a new service, we keep moving through it with a new service. The only time that you can actually break this is if you create a new scope. The way that you create a new scope is using this request services. So for example, I create scope. This is going to be a new scope. Okay. And for the beginners, I will explain this in just a second. You can put a using statement. So let's quickly put this over here. This scope exists for about yay much, where you can use the scope the same way that you're using the HTTP context over here. So once you go to the scopes service provider, you can get the required services. This can be the var GUID2, let's say, and we're gonna put it over here. Okay, GUID2. Let's wait for the application to restart, refresh. So for the duration of the request, 0FF is the same thing that we're getting over here, but once we create a new scope over here, we're getting a new scope of services, of scoped services. This is effectively how you can create it. And if you don't understand the word scope, right, for my non-English speakers, if you have variable a here and you have variable a here, you effectively stop understanding that it's the same thing that exists in the same place. I cannot allow you to have this. So many programming languages will effectively do this. So what you can do is you can say, okay, A exists over here and this A exists over here. So now that they're in different scopes, they exist in different places, okay? So this is like a mental circle that you can draw in your mind for where these services are going to exist, okay? So let's remove this gunk over here. So singleton, scoped. Let's take a look at transient. Transient, super simple. I think the hardest thing to understand is the scoped service. But yeah, oh sorry, I was meant to go to transient. Let's take a look at this. So application has restarted. Hopefully shouldn't come as a surprise. We have F8 over here. We come back to the code and we take a look at this, and it's a new GUID every single time. Every single time we resolve the service, it's going to be a new GUID. This is not to say that the service is going to have a new GUID every single time. It's just that anytime we're getting the ID, we're asking for a new instance of the service. If we are reusing the same service with the same identifier, it doesn't magically get recreated under the hood. You will see that it's still printing the same value. It's the same instance, but it's a new instance every single time you request it. Okay, so we don't need that over there. And there we have it. So the three main lifetimes, and by the way, if you are trying to use a service that you haven't registered, so for example like this, if you try to reach this, you're going to get an exception. And yeah, it's going to tell you no service for type GUID service has been registered. You're going to be like, oh yeah, actually need to register my service with the dependency injection container. Register your services and use them when you're processing the request. When you are a ASP.NET Core developer, most of this has been taken care for you, and what you're doing is you're just registering your routes, you're installing a package, and you're adding something like, for example, builder, services, add MVC, and now you have model view controller pattern, which is not exactly model view controller, but under the hood, this is gonna register tons of services, which are like at singleton, at scoped, a bunch of providers, factories, etc., which allow for MVC to work. So you register a bunch of services, those will have to be consumed in some middleware. So you go app, use, let's say, I think MVC over here, and that's pretty much it. That's the whole pattern when you're using ASP.NET Core. Now, a little bit more on services. Here we have a super simple service. We can have a parent service. Okay, the parent service, let's use the new C# syntax. I don't know if it's gonna figure this out, that this is okay, and yeah, it does know. So the parent service in its constructor is going to accept a GUID service. Okay, and the parent service, let's say we're gonna be returning a string ID, and this is going to evaluate to parent underscore, let's put a $sign over here, GUID, and semicolon. Okay, once you take the parent service, you go to program CS, and let's say I'm gonna copy this over here. I'm gonna still use the parent service, So on its own, it's not going to automatically detect that you need the GUID service. So let's take the parent service and we're just going to replace it over here. So rename the variable parent service. So let the application restart, give it a refresh, and I think it was still restarting, or what's going on? Let me start this again. Okay, so it didn't manage to start because while it was creating the parent service, it couldn't find the GUID service, which is understandable. So you didn't get this error at the time of executing the request, you got this error at the time of registering your services. So you will still need to register the child dependencies for your other services. So if you have a service that depends on a service, you will need to register both services. So the application restarted and I got forced into the browser, but here is the result. You can see here I made a little bit of a mistake where the GUID service got automatically converted into a string. But with that changed, you should now be getting a correct GUID. So that is about all I wanted to teach this. As long as you understand with ASP.NET Core that you're making a request, you're processing it, and in order to help the processing phase of the request, you have dependency injection, where you're orchestrating your services into some kind of component, which is going to process the request, yield some kind of result, and then you write it back to the response. And that response appears in the browser. So let's go through this. Let's say I don't want to be using endpoints, I don't want to be using any of this and none of this. I want to be using controllers. Effectively, the incoming request, instead of doing app.map, map get, I want to just use controllers. So in the builder over here, I'm going to go to services and add controllers. So controllers is just a different way to define how I want to process the request. On the app, there should be a map default controller route. Okay. And now usually how you would use it is you would create a controllers folder, and in the controllers folder, let's say something like home controller.cs. So this is going to be a class, and you can put it as controller or controller base. And then we're going to create an action, which is going to return a string. If I remember correctly, you call it index. And yeah, let's just return hello world from here. Okay. Mark it as HTTP GET. So on HTTP GET request, if it's going to match hello home index, we're going to return hello world. I'm going to just put about page over here just as an example. Format the document. So I'm noticing I'm saving this and my application is not refreshing. So let's just quickly give it a restart. I don't know if it's because it's a new file. So after rebuilding, we see the hello world over there. Let's say I'll add a new line, save. Okay, and it's refreshing. Cool. So if I visit the the root, because it's home index, the convention is that it automatically visits this route. So if it's home index, it's also the same thing. If it's home/about, I get hello world too. Okay, this is just one way where you can add some services, and then you basically get some stuff in the middleware as well. Most of the time, if you're grabbing a package and you're adding some services, it's just going to be an additional thing that you can inject into your actions, into your controller, etc. As long as you understand that ASP.NET Core is about receiving a request, assembling your services in order to process that request, whatever results you get back, you actually write it back to the response, and then it is received in the browser. Everything else about ASP.NET Core are people building libraries which are perhaps standalone services which give you some kind of class, or are services in conjunction with middleware that help you process the HTTP request. And that is pretty much all there is to ASP.NET Core. All you have to do now is just learn all the amazing tooling that is currently available in the open source ecosystem of ASP.NET Core and just generally .NET. Hopefully you've enjoyed the video. Don't forget, if you did, leave a like and subscribe. If you have any questions, again, make sure to leave them in the comment section. If you would like to support my work further, please come do so on my Patreon. You can get the source code for a bunch of videos that I did previously. I'm not going to be uploading the source code for this video because it's very trivial. I'm more explaining concepts, but a very big thank you to all of my Patreon supporters that are currently supporting me. You help me make this work. As always, thank you for watching. Have a good day.